Welcome to an extraordinary journey into the heart of the cosmos, where the birth of elements unfolds in the fiery crucibles of stars. This is the story of stellar nucleosynthesis, the process by which stars forge the building blocks of the universe. From the simplest hydrogen atom to the heaviest elements, the life cycle of stars is a testament to the fundamental forces that shape our cosmic destiny. Today, we'll explore the intricacies of this celestial alchemy, from the basic concepts of nuclear physics to the observational evidence that confirms our understanding. So, let's embark on this cosmic voyage and unravel the mysteries of how stars create the elements that make up our world and beyond. Stellar nucleosynthesis is the process by which elements are created within stars through nuclear reactions. This phenomenon is a cornerstone of astrophysics, providing insights into the composition and evolution of the universe. The significance of nucleosynthesis lies in its role in creating the elements necessary for the formation of planets, life, and the myriad structures that populate the cosmos. The concept of nucleosynthesis was pioneered by visionary scientists like Fred Hoyle. In the mid-20th century, laid the groundwork for our modern understanding of how stars create elements. Hoyle's work, along with that of other luminaries, revolutionized astrophysics, offering a glimpse into the stellar furnaces where the elements are born. To grasp the essence of nucleosynthesis, it's crucial to understand the structure of atoms and nuclei. Atoms are composed of protons, neutrons, and electrons, with the protons and neutrons forming the nucleus at the atom's core. The arrangement and interactions of these particles are the foundation upon which nucleosynthesis occurs. Nuclear reactions are the transformations that occur within atomic nuclei. Fusion and fission are two primary types of nuclear reactions, but it is fusion that powers the stars. In fusion, lighter nuclei combine to form heavier ones, releasing vast amounts of energy in the process. This is the engine that drives nucleosynthesis in stellar cores. Stars are born from the gravitational collapse of interstellar clouds, known as nebulae. As these clouds condense, they fragment into smaller clumps that eventually form protostars. The immense pressure and temperature at the core of these protostars ignite nuclear fusion, marking the birth of a new star. Once a star reaches the main sequence phase of its life, it begins to fuse hydrogen into helium in its core. This process, known as hydrogen burning, is the primary source of a star's energy and can last for billions of years, depending on the star's mass. As stars exhaust their hydrogen fuel, they evolve into red giants, expanding and cooling as they fuse heavier elements. For massive stars, this phase culminates in a spectacular supernova explosion, scattering newly forged elements into the cosmos. In stars like the Sun, hydrogen burning occurs through the proton-proton chain and the CNO cycle. These processes convert hydrogen into helium, releasing energy that sustains the star's luminosity. Helium burning is the next stage in a star's life, where helium nuclei fuse to form carbon in a process known as the triple alpha reaction. This reaction is a critical step in the synthesis of heavier elements. Elements heavier than iron are formed through the S process and R process during the late stages of stellar evolution and supernova explosions. These processes involve the capture of neutrons by atomic nuclei, leading to the creation of a diverse array of heavy elements. Low-mass stars, like the Sun, primarily produce helium and some carbon and oxygen. In contrast, high-mass stars are capable of synthesizing a broader range of elements, including those heavier than iron, through their more energetic nuclear reactions. Supernovae are cataclysmic events that mark the end of a massive star's life, dispersing newly formed elements into space. Neutron-star collisions, another high-energy phenomenon, also contribute to the synthesis of heavy elements, enriching the cosmos with precious metals like gold and platinum. Astronomers use spectroscopy to analyze the light from stars and nebulae, identifying the elements present through their unique spectral signatures. This technique has provided invaluable evidence supporting the theories of nucleosynthesis. The observed cosmic abundances of elements, from hydrogen to uranium, align remarkably well with the predictions of nucleosynthesis theory. This concordance between theory and observation underscores the validity of our understanding of how elements are formed in the universe. Nucleosynthesis has profoundly influenced the chemical evolution of the universe, seeding the cosmos with the elements necessary for the formation of planets and the emergence of life. This process is a fundamental driver of cosmic diversity and complexity. Stellar nucleosynthesis is intimately connected to the broader narrative of cosmology, including the formation of the earliest elements in the universe through Big Bang nucleosynthesis. This link between stellar and cosmic scales highlights the interconnectedness of all phenomena in the cosmos. Stellar nucleosynthesis is the wondrous process by which stars create the elements that compose the universe. From the nuclear reactions that power stars to the spectacular supernovae that disperse these elements into space, the life cycle of stars is a testament to the fundamental forces that shape our cosmic destiny. The synthesis of elements, from hydrogen to the heaviest metals, is a key driver of the chemical evolution of the universe, influencing the formation of planets and the emergence of life. The story of stellar nucleosynthesis is a tale of cosmic creativity and the relentless pursuit of understanding. Whether you're intrigued by the nuclear physics at the heart of stars, the life cycle of stars, or the broader implications for the universe, there's no better time to delve deeper into this fascinating field. Whether through observation, theory, or simulation, the study of nucleosynthesis offers endless opportunities for discovery and learning. So, let your curiosity guide you. And who knows? You might just uncover the next breakthrough in our understanding of the cosmos. Thank you for joining us on this cosmic voyage into the heart of stellar nucleosynthesis. The principles we've discussed today are not just theoretical abstractions, but the very fabric of the universe. As we continue to unravel the mysteries of how stars create the elements, we stand in awe of the cosmic alchemy that shapes our world and beyond. Stay curious, keep exploring, and who knows, you might just write the next chapter in our understanding of the universe. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.